Dear students, today we are going to discuss about respiratory quotient. Is in the last lecture we discussed about that, and we also finished about the one way how to count respiratory quotient. Today we are going and trying to learn this respiratory quotient by another way, that how we can calculate that. Respiratory quotient is actually the ratio taken in carbon dioxide release. When substrates are respired, the ratio of the volume of oxygen used and carbon dioxide given are different. It follows that this ratio called respiratory quotient. Which substrate is being used in respiration, it shows us that actually respiratory quotient show us that which substrate is being used in respiration. Right now, for example, here I am taking respiratory quotient for glucose, right? So if you check here, according to this equation, according to this equation, for example, how much oxygen consumed, this is equation for respiration. In the presence of oxygen, breakdown of glucose take place or oxidation of glucose. So here oxygen utilized with you, right? Now what you have to do, you have to, according to respiratory quotient formula, it is actually the ratio of oxygen taken and carbon dioxide release. So RQ value formula, we have carbon dioxide divided by oxygen. So in this equation, right, 6 oxygen utilized and 6 carbon dioxide released. So you will put the value here. It means 6 by 6. So the respiratory quotient here we have 1. It means amount of oxygen is equal to that of carbon dioxide. Okay, if 6 mole of oxygen consumed for the respiration, 6 mole of carbon dioxide produced. So this shows us that the substrate is glucose. Right? Now, you can check here in this equation, same equation, carbon dioxide and then oxygen, so ratio is 1. When fatty acid such as oleic acid is respired aerobically, the equation is like this. So for this equation, if you put this value in the respiratory quotient equation, so you may get the value different for fatty acid. Right? So let's suppose this we have oxygen utilized, so put the value here in the presence of oxygen, right? In place of oxygen, and for carbon dioxide 18. So if you divide 18 by 25.5, so you will get this value. It means that the respiratory quotient for glucose is high as compared to fatty acid. Why this respiratory quotient of glucose is more than fatty acid? Because, you know, here if oxygen utilization is more, respiratory quotient will be less. Am I clear up to here? If oxygen utilization is more, respiratory quotient will be less. Why? It means that this oxygen increase than that of fatty acid. It means that oxygen utilization here is less in glucose, while here oxygen utilization is more. It means for the respiration of fatty acid need more oxygen. That's why our respiratory quotient go down. It means that is inversely proportion. If you check here, if remember, oxygen utilization is increasing, RQ value will decrease. And why this is happening? Because the fatty acid structure is a bit complicated, that having more oxidation, initially we need more oxygen to convert that fatty acid into acetyl CoA. So for that reason, this in respiration of fatty acid, it needs a bit more oxygen as compared to glucose. Same for protein. Now let's check how we can find this practically. RQ value, how we can do practically. So these are different substrate, carbohydrate 1, lipid 0.7 and protein 0.9. So what happens when respiration is not aerobic? Like for example, we are taking here example of yeast, right? So in this equation, if you check here, the anaerobic respiration of glucose happen, right? And that produce alcohol plus carbon dioxide. It means in anaerobic respiration, no consumption of oxygen happen. So that's why when I put my value in this equation, so H will be 2 by 0. So it will move to infinity, right? So for that, I can't find RQ value, right? But in reality, some respiration in yeast will be aerobic. If in this time a little bit aerobic respiration happen, so a small amount of oxygen will taken up and the RQ value will be less than that of infinity. Right? Now, for if you move toward your muscle, in muscle glucose converts into lactic acid. It means no utilization of oxygen will take place, right or no?
Yes.
For that, can you put this value in that? How we will put the value? If here, check it here, glucose converted into lactic acid anaerobically, no oxygen utilized, and even no carbon dioxide produced. Right or no? So for that reason, if you do it and you put that value, it will be like this. 0 by 2, it's 0 indicate you what? No carbon dioxide, right? And even here is no 2, no need of 2, because no oxygen utilized. Right or no? So it means that we will take it 0 by 0. 0 by 0 means nothing. No RQ we can calculate for muscle using lactic pathway, because no utilization of oxygen and no carbon dioxide is produced. Is it clear up to here?
Yes, sir. Yes, sir.
Okay. All right. So a respirometer, set up apparatus through which we are measuring rate of respiration. So oxygen uptake during respiration can be measured through respirometer. So a respirometer, actually the principle of respirometer is consumption of oxygen. It means if oxygen consumption is more, so rate of respiration will be high. Let's see. If you check here, for example, here I'm considering any insect, non-vertebrate, right? And putting that on net or gauze platform, right? And so that there may be no, we are putting this gauze so that there should be no interaction, like that, sodium, soda lime and potassium hydroxide is toxic for this insect, so that there should be no, insect should not be in that, to prevent insect from that. So for that reason, we keep it between that. And after that, we put here soda lime to absorb what? Carbon dioxide, right? Because we know that in the process of respiration, oxygen consumption will take place and carbon dioxide will produce, right? Now, through this respirometer, I am checking, I'm going to find what consumption of oxygen. If this insect is absorbing more oxygen, So it means the pressure inside the tube will decrease. If the pressure inside this tube is decreasing, right, it show me that rate of respiration is high. Why? Because this oxygen need for the consumption of glucose. Now, at the same time, carbon dioxide will produce. In that carbon dioxide will absorbed by soda lime. So our experiment will not be affected, it will be balanced. Now, in this side, you can check here, this side, actually you will take the value from this manometer, right? This is a, graduated tube containing fluid, right? A liquid, color liquid. This liquid show you that, that how much oxygen utilized. For example, oxygen here utilized more, so this liquid will move toward that insect, right? Because the pressure inside that will decrease, so this fluid will move up. If this fluid is moving more up toward left to that insect, it means in the presence of, if it is moving toward that insect, it means that pressure is decreasing because oxygen consumption is more, right? In the presence of soda lime, because soda lime have to absorb that carbon dioxide. If there is no soda lime, then, if, listen very carefully here. For example, I'm not keeping here soda lime, right? I'm just discussing this part of this apparatus. If I'm not putting soda lime, so what will happen? If it is oxygen, 1 mole oxygen is utilizing, 1 mole of carbon dioxide will produce, right? So it will remain same, that's liquid. But now listen here very carefully here. That will remain same. But for example, if the oxygen utilization is more and carbon dioxide production is less, right? So it means this will a bit go up, not much, right? Yes. When it is going up, it show me that the substrate is not glucose. The substrate is not glucose. Am I clear?
Yes.
I mean
the difference between carbon dioxide and oxygen.
Yes, it means that oxygen consumption, listen me very carefully. If oxygen consumption is more and carbon dioxide is less, right? So this liquid will go little bit up, right? It means that in presence of glucose, carbon dioxide and oxygen same, right? For that this liquid will not move if there is no soda lime. But if there is no soda lime and still this liquid move toward left little bit, it means that oxygen consumption is more than what? More than
carbon dioxide production.
More than carbon dioxide, right? In that case. Now let's suppose we have another case. If we have no soda lime and this liquid move toward, check here, and this liquid move toward that side. So what I can conclude from this? If there is no soda lime and this liquid move little bit toward the right
then
side,
carbon dioxide production is more than oxygen consumption.
Very
more
good.
Than the
Correct.
oxygen production.
Correct. It means carbon dioxide production is more than oxygen production, right? Good. Up to here, I think the concept is clear. We will utilize this concept later on. Now, this tube, you will think that why we put this tube? This tube, we just keep it as a control. In this, we put what? Glass bead, so that will not do respiration. Right or no? So it means this tube, here is no, here is no consumption of oxygen and no consumption of carbon dioxide. So this liquid will. Dear students, up to here your concept clear about the difference between two substrates, glucose and lipids or protein. And up to here we learned that for the lipids we need more oxygen. So let's suppose we are considering case 1. In that case 1 I will consider glucose. Okay, glucose is a respiratory substrate. In this case, glucose, we have respiratory substrate. So if the, if the breakdown of glucose happens, C6H12NO6 plus 6O2 goes to C6O2 plus water plus energy, right? So in this case, as you studied that in this case, equal amount or equal volume of oxygen will utilize to that of carbon dioxide. Means carbon dioxide in oxygen, if like 6 mole of oxygen is utilizing 6 mole of carbon dioxide will produce, right? So the RQ value for this is 6 by 6 is equal to 1. RQ value in this case will be 1, right? In this case, you check already in the experiment that we put soda lime in that, and the drop was moving, the drop in that respirometer, it moved toward where it moved toward the left side, right? When we are doing this practically, we will check, we will find the drop, the distance that covered by the drop, right? So that will show us volume of oxygen, that how much oxygen utilized. Okay, let's suppose that they drop travel approximately 20 distance when I was performing this practically, right? So I have to find that by a formula, that how much volume of oxygen utilized. So in that case, for example, it's moved 20 so I will put that in a formula, phi r square h, right? So phi is constant value 3.14, right? R is actually the radius of this tube, which tube you are using. So let's suppose the radius of the, R is the radius of this tube. So let's suppose the diameter of this tube, I have 1 So definitely the 1 divided by 2, so the radius should be 0.5. So in this formula, I will put 0.5 square, right? Multiply this, h is the distance that covered by that drop. So it is what? 20 Okay, so it will give you the value of oxygen utilized. So in case of glucose, this volume will be same to that of carbon dioxide. So this value, we got it, what it is, approximately it is 15.7 millimeter cube oxygen utilized. So if we are performing our experiment, right, if the substrate is glucose, right, and this drop move 20 right, so it means that 15.7 oxygen, cube oxygen utilized. So it means that 15.7 cube carbon dioxide produced, right? So the RQ value for that will be 1. Okay, now in this case, it was in the presence of soda lime. So how we will make sure that it was exactly the substrate was glucose and there is no extra oxygen utilized? We will do this same experiment in the absence of soda lime. We will do the same experiment in the absence of soda lime, right? In the absence of soda lime, what should be the expected result? If this value is correct, so in the absence of soda lime, the drop of that, respirometer should not move. That drop should not cover, that distance. This distance should be not covered. Why? Because, in that case, if equal amount of oxygen, the oxygen utilization is equal to that of carbon dioxide production. So it means inside that respirometer, the pressure will remain same. If pressure remains same, so that drop should not move, right? If the drop doesn't move, so it means that our substrate was exactly glucose. Is it clear up to here? Now we are going to consider another case. Now let's suppose we have case 2, right? In this case, in this case, our respiratory substrate is lipid or fruity, right? So when we perform that experiment in the presence of soda lime, when we perform that experiment in the presence of soda lime, presence of soda lime. So what happened? Definitely, like, the drop of that respirometer, the drop within the respirometer that moved to our left side, that show us that oxygen consumption, okay, while the carbon dioxide that was producing that already absorbed by soda lime. Okay, now the movement of this drop show us what? Oxygen utilization. So it means that if, as I discussed with you already, that equal amount oxygen utilization, the amount of oxygen utilized was equal to that of carbon dioxide, right? So this drop moved toward that side, and when I find it, the volume of this oxygen utilized, so it was approximately, I'm just taking a supposition, so it is, for example, I got it the value 30 mm³ value when I find it through formula, right? So it means that this volume of oxygen utilized, this amount of carbon dioxide should be absorbed by soda lime. So it means that oxygen is equal to what? Carbon dioxide. So it means X is equal to X. I have to put this in RQ formula. So, right? So this is same. But, when I perform this experiment in the absence of soda lime, so what happened? This supposed to be like, it's supposed to be remain same, because if it is following this condition that equal amount volume of oxygen utilized should be equal to that of carbon dioxide production, but it doesn't happen like this. What happened when I perform the experiment in the absence of soda lime, right? So that drop moved toward a little bit, moved toward the left side. That show me that oxygen utilized, that still oxygen utilized. And approximately when I find that value, so for example, it came with me 6 mm³ oxygen utilized. So this show me that this is the extra oxygen that need for the lipid metabolization or for the initial oxidation of lipids, right? Because as I discussed with you already, that lipids contain more carbon hydrogen bonds, and for that initial oxidation, for breakdown to convert into acetyl CoA, that need more oxygen is compared to glucose. right? So this extra oxygen, actually, when I count it, if you check it here, this value just come toward this equation. This was 30 over 30. It means that when I was counting this oxygen, right? So this oxygen, I take it equal to that of carbon dioxide. So it means that when I do this experiment, when I perform this in the absence of soda lime, still that move. So it means that in this carbon dioxide, in this value of carbon dioxide, I counted that extra oxygen. I counted that extra oxygen. It means oxygen is more than that of carbon dioxide. Therefore, this extra oxygen, I have to minus it. So 30 minus what? 30 minus 6, right? Divide by 30. Now the up means carbon dioxide, this one is, this 30 indicates you this carbon dioxide evolved in the presence of soda lime, and this show you oxygen evolved in the absence of oxygen utilized, volume of oxygen utilized in the absence of soda lime. So we have this up value total, I will represent it by x minus y. So this x minus value actually show me total carbon dioxide evolved during respiration of lipids or protein. X minus y divide by x. If when I divide it by x, it will give me RQ value for lipids or protein. The x is the volume of what? Oxygen. Is it clear? Now up to here it's clear. When you find it, so it should be 24 by 30, right? So it means oxygen utilized the downward, this is oxygen utilization is more, volume of oxygen utilized is more than that of carbon dioxide. So it means our substrate was what? Lipids are protein. And there is a table that I show you that when you do it practically, if the value come with you 1, that will be carbohydrate. If it is 0.7, it will be with you lipids. If it is 0.8 or 0.9, so that should be protein. Is it clear? That is approximately approximate value that I showed to you already in the table. So I hope up to here this is clear. So let's suppose we are going to solve a question, okay, about that. So calculate the missing value in the table. So the same formula we will use for that. Okay, so what is that? The same formula we will use for that. Let's see. This is volume of oxygen absorbed with soda lime, right? So it means this is x, right? X is actually volume of oxygen, the downward volume of oxygen. So that volume of oxygen is equal to that volume of carbon dioxide, right? As we did already in the formula. Now volume of carbon dioxide evolved. Here volume of oxygen absorbed with no soda lime. So it means that Y is not given to us. Y is not given to us. Y is a question. But you know, the volume of oxygen absorbed with soda lime, this down x is given to us. This is 46. This is what? 46. Okay, while total, you can check it here, volume of carbon dioxide evolved, total volume, it means x minus y is given to you. X minus y is given to you what? X minus y is given to me, that is 37. This is total volume of carbon dioxide evolved, x minus y. So x minus y is equal to 37. The x value is given to me already 46. So I will put it here 46, right? Minus y is equal to 37. Okay, so what I have to do, I have to find the value of this y. So the y should come toward that side, so definitely the sign will change to plus, and this 37 should come toward that side. It means that 46 minus 37, so it will give me which value? It will give me approximately, yeah, it will give me 9. Okay, so I will put 9 value here. Okay, then they are asking from me the RQ value. So for RQ value, what I have to do, I have to divide that, you know, carbon dioxide, that for the RQ value, I have to also use this formula. So x minus y with me is what? X minus y is already given to me, 37 by 46. So it will give me the RQ value for this. Okay, you will get this value. Okay, I hope up to here this is clear. Now let's come toward the another B. How you will solve it? Volume of carbon dioxide evolved, they are asking from us. So again, you will put that same formula, x minus y divided by x, right? So put the value, uh, volume of oxygen absorbed with soda lime is given to us, the down x, it is how much? 39. Okay, so I put it here. Now volume of oxygen absorbed with no soda lime, it means this is the value of y value is 0, right? Minus what? Volume of carbon dioxide evolved, volume of carbon dioxide evolved. So volume of carbon dioxide evolved is equal to what? X minus y, and the x value I know already, that is 39, right? So x minus y show you what? Volume of oxygen evolved. So it will be equal to 39 minus 0, it will be equal to 39 by 39. Okay, so if you divide that, so it will give you 1. So the RQ value here should be 1, and volume of carbon dioxide evolved, it should be 39. Okay, it is 1, so that substrate should be what? Carbohydrate. So for the another also you can do the same, like, you know, you can use the same formula. You know, volume of oxygen absorbed is given to you, x is given to you, what is this? 41, right? And volume of oxygen absorbed with no soda lime, that is given to you, y, right? So y is how much? 12, right? And volume of oxygen absorbed with soda lime, 41 is given to me. Volume of carbon dioxide evolved is not given to me. Okay, so we know volume of carbon dioxide evolved is equal to what? X minus y. Okay, so y value is 12 and x value, I will count this one because volume of oxygen equal to volume of carbon dioxide. So 41 minus 12, if I 41 minus 12 I do it, so it will give me the answer for that. So the answer for that should be 41 minus 12, so it should be 29. So you can put it here, 29. Okay, the RQ value you can find it by using this formula. RQ 41 minus 12 divided by 49, it means 29 divided by 41. Yeah, 41 minus 12 divided by 41. Okay, so 29 divided by what? 41. Volume of carbon dioxide evolved divided by 41. So it will give you the RQ value for that. Is it okay? And the same you can also do it by the same formula, volume of oxygen absorbed in the presence of soda lime. Okay, so you know that volume of carbon dioxide evolved. So let's use this formula once again. X minus y is equal to x minus y divided by x, right? So volume of oxygen absorbed with no soda lime, it's given to me, that is what? That is given to me 12. This is given to me 22. That's given to me 22, right? And so x minus 22, right? Now x minus 22. Now the value that I have to put this value right now. So put this value here is volume of carbon dioxide eval is what? X minus 22 is equal to what? It is 54, right? So this volume of oxygen eval is it actually what? X minus y. So x minus y is equal to x minus 22. Y value already given, y value already given to me, that is 22, right? So x minus 22. So to find the value of x, so what you have to do, 54, and that 22 will go to that side, so plus 22, x will remain here, right? So if you do it here, so it will give you 6 plus it, 54 plus 22, 6 and 5 plus 2, 7, right? Yes. So the value of that should be 76. It should be with us. What volume of oxygen absorbed should be 76, right? Now if you are finding the RQ value, for RQ again, what you have to do, you have to, volume of oxygen, you have to use again the same formula. Okay, put the x minus y value divide by x. So the x value already given to you 76, and here you should put it here 76. Just x value is given to you minus y, so y is what? 22. Am I clear? So 76 minus 22, so it will be give you 54. That this value of carbon dioxide, so it means volume of carbon dioxide evolved divided by that of volume of oxygen absorbed with soda lime. So it will give you the RQ value, and from that you can that what is, so it's supposed to be 0.7. If it is 0.7, it means that will be liquid, that substrate liquid. Wise calculating respiratory quotient, how we will do that? Glucose is, as I discussed with you, glucose is not the only molecule that can be respired, right? Glucose is not the only molecule that can be respired. We have also other respiratory substrates like fatty acid, amino acid. So let's see how we can find that RQ for that specific substrate. Example formula for this, we have respiratory quotient carbon dioxide produced, carbon dioxide, oxygen consumed. How we will do work with this? For example, they give us palmitic acid and they are asking from us that find the respiratory quotient for that. Okay, find the respiratory quotient for that, and what we will do? If you find respiratory quotient for that, in what kind of substrate it's supposed to be. Check it here. The first step that when you are going to deal with such a question, so first you have to mention this chemical formula for that. And from your knowledge, you know that for respiration, we need oxygen. So definitely you will mix with that oxygen, how much oxygen consumed. Then you will write carbon dioxide plus water. Up to here, you will remain only journal. After that, you will start to balance both sides so that I know that how much carbon dioxide produced and how much oxygen consumed. So the first step is the number of carbon dioxide is equal to the number of carbon atom in the substrate. Count the number of carbon atom in this substrate. So let me check how many carbon atom we have. 1 and 15. I have or no? Yes. So total number of carbon atom I have 16. So I will make it like this, 16 carbon dioxide. Okay. Now still for water and for oxygen remaining. So what value I will put? The number of water molecule is, remember, third step you will follow this. The number of water molecule is equal to half of the atoms in a substrate, hydrogen atom in that substrate. You have to follow this step. So let's count it, number of water molecule, half of hydrogen atom in substrate. So how many hydrogen atom I have in this substrate? 1 hydrogen and this one 31, right? So total number I have 32. So 32 divide by 2 because I have to take it half, right? So what it will give you? Tell me. Yes, if you divide 32 by that, so it will give you by 2, it will give you 16. Okay, so I will put it here. What? I will put it here 16. Up to here, this is clear. Now balance the number of oxygen atom on each side. Now you have to balance the number of oxygen in each side. Both sides counted. So this side is completed already, right? So count the number of oxygen on that side, okay? And then we have to balance. So let's see the number of oxygen here. We have 16 multiplied 2. So total 32, right? So 32 plus 16 multiply 1 with oxygen, right? This is chemistry. So 32 plus 16, how much I have? 8, right? Yes, 48. Okay, or no? Let me count once again. So 16 multiplied 2, 32. And 16 multiply 1, 48. Okay, 16 multiply 1, 16. So it means 16, this one, so 8, 3 plus 1, 42. Up here, this is clear. So from one side, I have 48, sorry. Now from this side, let me check these. One oxygen is this, one is this. So 2 oxygen, right? And this before, before the equation, you can check it. 1, 2, and 2, 4. 4 on this side I have. So 48 minus 4, how much? 44. 48 minus 4, how much? 44, right? Yeah. Boys, let's see here. We will not count this, we will not take this 4. Okay, we will take only 1 and 2. Only 2, because these 2 oxygen I will count it with complete. So it means this side I have 2, and with this side what I should put it here so that it give me 48. So that it give me 46, because these 2 I will add with that. So let's see here, if I put it here 23, so 23 multiply 2. So what it will give you if you multiply 23 with 2? So 3 to the 6 and 2 to the 4, 46. So it means 46 these and these 2, right? So 46 plus 2, it will give you what? 46 plus 2, 48. So it means this side is this side now balance. 48 is equal to 48. Okay, now find the respiratory substrate now. Respiratory quotient. Respiratory quotient is actually carbon dioxide produced divided by oxygen consumed. So let's see, carbon dioxide molecule we have produced how much? 16. So put the value here, 16, right? Divide by 23. 16 divided by 23. Okay, if you do it, it will give me 0.69 approximately, right? So approximately this is 0.7. So from here I understand it according to my values, right? That respiratory quotient for fats will be what? 0.7, for carbohydrate will be 1, and for protein that will be 0.9. So according to that, I know that I figure out that this respiratory substrate, palmitic acid, this belong to which category? Belong to lipid category. Is it clear up to here? If you having any question related this, you can ask now. Okay. All right, boys. The first for the glucose, we already wrote the equation, right? Now you have to find it. Oleic acid, right? Equation for that, write the equation for that, balance it, and then find the respiratory quotient for that.
Which one should we do, A or B?
B, glucose already finished. Now, please just show me. Boys, if you follow that step for oleic acid, so you can, when you balance you know, like if you follow the step and you balance it from both sides, 25.5 oxygen and 18 carbon dioxide and 17 water, and you put that in the equation. So like in that equation means like 18 divided by 25.5. So you will get your respiratory quotient value, right? Same this formula, just put it here. In this formula, if you fit it, carbon dioxide produced on oxygen. So it will give you the value of that respiratory quotient for oleoic acid. So let me ask from a student. Okay, Muhammad Khalid Jara, what is your value?
My value, which one for which B?
Yeah, for B, oleoic acid.
0.7.
0.7 means, okay. What did you do? What you divide by what?
18 over 25.5.
Good, good. So to which category this belong?
Olic
To which?
acid. What do you mean?
Good. To which, sorry, to which category this belong? This
What do you mean
0.7
category?
for the lipids, right? Like to which
Yeah,
respiratory
lipids.
substrate.
Oh, yeah, lipids.
Okay, good.